Today we're going to be looking at special triangles. So we're starting in Matthew C, Geometry Lesson 20. And this one today is going to be about 45, 45, 90. But first, we're going to just talk about what have you noticed about the length of the sides of triangles compared to their angles? Have we looked at that before? So if I have a triangle, it looks like this. This is the shortest side. Across from it is going to be our smallest angle. Now, this straighter side on top is a little bit shorter than this one across because this looks like it could be a 90-degree angle. This could be a right triangle. And we know in a right triangle that the hypotenuse, the one across from the 90 degrees, is our longest side. So then this is a pretty big angle. It's across from the one that's pretty long, but not quite the longest. So if we have a right triangle, where is the longest side? It's across from the right angle. We call that the hypotenuse. Remember, that's the name of the side of the one that is across from the right angle. If you have an isosceles right triangle, what are the other two angles going to measure? So an isosceles right triangle, let's see if I can draw a good one. This side is the same length as this side, and this is a right angle, and here's our hypotenuse. So if these two are the same length, what are these angles? Hopefully you've said 45 degrees, because in a triangle, we have a total of 180 degrees. If we subtract our right angle, then we're left with 90 degrees. For the other two angles, if they are exactly the same, then we take the 90 degrees and we divide by 2. So they're 45 degrees each. Using the Pythagorean theorem, we're going to explore the relationship of the side lengths in a 45 degree, 45 degree, 90 degree triangle. For short, we just say 45, 45, 90. But you're having to understand that that is the degree measurement of the angles of the triangle. So I look at this and I see an isosceles right triangle. It's inside of a big square. So the legs are the same length. That means that these angles are the same and they're half of what's left, which is 45, half of the 90 that's left, which is 45 degrees each. Pythagorean theorem says that a squared plus b squared equals c squared. C always being our hypotenuse. So let's say that one leg is 6 inches. We're going to call this one 6 inches. This square is a 6-inch square. So what is the other leg equal to? 6 inches, because they're the same over here. What is the hypotenuse? Well, we're going to take our formula and we're going to say 6 squared plus 6 squared equals c squared. And I'm going to take the square of 6. So 36 plus 36 equals c squared. 36 and 36 is 72 equals c squared. And to get just c, I have to take the square root of both of these. So I'm going to leave it right here for a second. 72 equals c. Now we've been working with radicals. That was last week's lesson. And this is why, because we need to be able to simplify this. I just added 36 twice. So 2 times 36 to get my 72. When I have things multiplied inside the square root, if there's a perfect square, We can take the square root of it and take it out. So the square root of 36 is 6. And the 2 is still inside the square root. And because we can't take 2 out of the square root, this is as simplified as it gets. So our hypotenuse is 6 square roots of 2 inches. Now, if you're confused on is this longer than 6 inches, the square root of 2 is, it's about 1.4. So 6 times 1.4 is going to be bigger than 6. So this is longer than our 2 legs. What if the isosceles right triangle has a leg of 10 inches? So I'm going to draw it again. This one is 10 inches. What is this side? 10 inches. What is this hypotenuse going to be? Well, let's see. A squared plus B squared equals C squared. Now we're going to have to do our exponents. So 100 plus 100 equals C squared. 200 equals C squared. Now we take the square root of both. And so we have the square root of 200 is equal to C. How can we reduce this? Well, again, we just added 100 plus 100 to get 200. So we have 2 100s, 2 times 100 inside the square root. 100 is a perfect square, so I can take that out. 10 square roots of 2 is equal to C. So our hypotenuse is 10 square roots of 2 inches. Are you seeing a little bit of a pattern yet? What if I label one leg as X? So let's draw that one again. This side is X. If these are the same, then this side is X. What is this one? Well, this is getting a little tricky, but let's see if we can do it. We would have A squared plus B squared equals C squared. C squared is our hypotenuse, but A and B are our legs of X and X. So we have X squared plus X squared equals C squared. If we add 2x squares together, it's just 2x squared equals C squared. And I can take the square root of both sides to try to get C by itself. So I have the square root of 2x squared equals C. Just like up here, I did 2 times 100 because 100 was a perfect square. Well, inside here, I see 2 times x squared. I mean, I can put my multiplication symbol back in there. And x squared is a perfect square. So I can take it out of the square root. The square root of x squared is just x. And then I have the square root of 2 left inside is equal to C. So hopefully now you really see the pattern. Whatever these legs are, you multiply that by the square root of 2 for the hypotenuse. So the rule is that the hypotenuse is the square root of 2 times the leg. We often write this as x square roots of 2 for the side lengths. And then if we know one of them, we can just plug that in. So what if I said that one of the legs is 5 of a 45, 45, 90 triangle? Well, you should just say, okay, well, if x equals 5, then the other x will equal 5. And then the x square roots of 2, well, I'll plug in a 5 right here. So that'll be 5 square roots of 2. And so I'm done. These are the lengths of my sides. We can also use this going backwards. It's a little bit trickier, but we can do it. We have a hypotenuse right here of a length of 7 centimeters. I know that these are the same and this is a right triangle. So what are the lengths of this isosceles right triangle? What are my L's, my legs? If we put our x, and x square roots of 2 up here, I'm going to say that L is then x and this L is x, and this 7 is x square roots of 2. So here's where it gets a little tricky, but let's see if we can look at it mathematically. So 7 is going to be equal to x square roots of 2. How do I get x by itself? Because that's what the other legs are equal to, just a 1x. I'd have to divide by whatever's multiplied by the x. So I'm going to divide by the square root of 2. Over here, that's going to cancel out, so I'm just left with x. So I have x is equal to 7 over the square root of 2. Can we leave it this way? Hopefully you said no. Last lesson, we learned about rationalizing the denominator. We have to make this a rational number. Right now, it's irrational because it's inside the square root. I do that by making an equivalent fraction. And I choose to multiply by what's in the denominator because 2 square roots of 2, or square root of 2 times square root of 2, will become not a square root anymore, right? Because now I have the same thing inside the square root, so it can come out. I have to multiply the same thing on the top and the bottom. Okay, I'm moving over here, but I have 7 times the square root of 2 on the top. And on the bottom, I have the square root of 2 times the square root of 2. That could also be the square root of 4. And the square root of 4, you can take out and make it 2. And that's equal to x. So what are the lengths of the legs of this isosceles triangle? Well, they're x, and since I just solved for it, I can say that it's 7 square roots of 2 over 2. Same thing down here. Let's do a few practice. Find the missing sides of the right triangle. So they said it's a right triangle. This one is 8 square roots of 2. What are G and H? We can think of it as x, and x square roots of 2. So this one will be the hypotenuse. So we'll have 8 square roots of 2 is x square roots of 2. So I want x by itself because that's what I'm solving for. So I'm going to divide by what's multiplied by x. Over here, that means the square root of 2 over the square root of 2 is 1. So I just have x. And over here, oh, look, that's nice. The square root of 2 over the square root of 2 is 1. So I'm left with 8. The other sides, G and H, are just equal to x. And I just said that x was 8. So that one was nice. Find the missing sides of this right triangle. This is my hypotenuse, and these are my legs. So if I use my x and x square roots of 2, this is a little tricky. Right here, our leg has the square root of 2. So I know that this one is at least the same. So this is 3 square roots of 2. But this one, I have to take x, which is the 3 square roots of 2. And then I multiply by another square root of 2. Well, I can multiply things inside the square root. So now I have 3 square roots of 2 times 2, which is 4. Oh, I know what the square root of 4 is. That's 2. So I'm going to take it out of the square root and I'm going to make it 2. I do need to multiply by what I already had. So now I have 6. So this is just 6. A little tricky, but that one wasn't too difficult. We didn't have to use fractions. All right, what about this one? Can I use my x squared of 2? No, these aren't the same. So I'm going to go back to my Pythagorean theorem. A squared plus b squared equals c squared. I'll put in 6 and 14 as my a and b. It doesn't matter which one I put where. I can do 14 and 6, or I can do 6 and 14. So 6 squared is 36, and 14 squared is 196. I need to add those together. 232. Now I'm going to take the square root of both sides. If you put it into your calculator, you're going to get a long decimal number, so that's not what we want to do. This is just C. So how can I factor 232? Can I factor 232? You know what? If I don't know, I'm going to go over here. I'm going to say at least it's divisible by 2. I know that much. So when I do that, I get 116. Well, that's got to be divisible by another 2. Might take me a while to get there, but I'm going to get there however I can. So when I divide this by 2, I get 58. And I see another 2 can come out. 29. Now I do need to know my primes to know when to stop. 29 is a prime number. It can't be divided again. So inside this square root, I have 2 times 2 times 2 times 29. So I can only pull out one set of 2's. 2 times 2 is 4. The square root of 4 is 2. So there's 1, 2 on the outside, and I'm left with these 2 still on the inside. So I can go back to 2 times 29 is 58. And I'm done. Let's see if we can get through lesson 21. All right, so lesson 20 was on 45, 45, 90. There's another special triangle that comes up very often, and it's a 30, 60, 90 triangle. So again, it's 30 degrees, 60 degrees, and 90 degrees. Let's see if we can find a pattern for this one. So here we are given 2 lengths of the legs and the hypotenuse right here we need to figure out. So these are just my a squared and my b squared, or my a and my b, and then I will square them. So I'm using the Pythagorean theorem to try to figure out what my hypotenuse is. 4 squared plus 4 squared, so 3 squared is equal to c squared. Well, 4 squared is 16. When I do this, I have to think about squaring the 4 and squaring the square root of 3. So the square root of 4, the square of 4 is 16 times the square root of 3 squared would be the square root of 9, and the square root of 9 is just 3. Oh, do you maybe see a pattern? How could I do this without actually adding them together? Right here, there is 1 16, and here I'm going to add 3 16s. So in total, I have 4 16s. And this might give us a little bit of hint as to how to do this. Then I can take the square root of both of these. Now I can multiply this together if I want, or I can take it separately, but we can go ahead and multiply together. 4 times 16 is 64. So the square root of 64 is 8, and the square root of c squared is c. So our hypotenuse is just 8. If I lost you on this one, you can just add them up. 16 and then 16 times 3, and if you add that all together, you'll get 64. Okay, so we found our hypotenuse was 8. So we're looking at this, we see 4 squared of 3, and 8. Okay, hold that. Let's do the next one, see if we can find a pattern. Okay, right here, we have 7 squared of 3. If you want to give a little guess, maybe put in pencil up here what you think your hypotenuse will be. We're going to use a squared plus b squared equals c squared. In this case, I'm just going to use the h to maybe help us out a little bit. Okay, so 7 squared is 49. I won't do my tricky little pattern here. Okay, so I'm going to square 7 and I'll get 49, and then I'm going to square the square root of 3 and I'll get 3. 49 times 3 is 147. $147 plus 49 is 196. Now I'm going to take the square root of both of these. Now, I don't really see, I don't know what that's the square root of. I could try my calculator, or I can try factoring a little bit. 196, let's see if it's divisible by 4. It is. It's 4 times 49. So if I'm taking the square root of 4 times 49, I can take the square root of 4, which is 2, and the square root of 49, which is 7, and then 2 times 7 is 14. So my hypotenuse is 14. All right, so this one was 7. 7 times the square root of 3 and 14. Are you seeing a pattern yet? Our rule here is that the short leg, this one right here, is half of what the hypotenuse is. In other words, the hypotenuse is twice the short leg. And then the longer leg is the square root of 3 times whatever the short leg was. So we often write this in that pattern with the x, and we say x, and that's our short leg, x times the square root of 3, that's our longer leg, and then 2x. So our short leg is x, our longer leg is x squared of 3, and our hypotenuse is 2x. If you come across and see the pattern in 2 of the lengths of the triangles, you can know that you have a 30, 60, 90 triangle, and you can solve it by the pattern instead of having to plug it all into the Pythagorean theorem. So here, you're not even given these angles, but you see a pattern. Oh, that short leg is 5 and the hypotenuse is 10. I feel like I've seen that pattern before. Maybe I can use the x, 2x, x squared of 3. And I can. This is 5. This is 2 times 5, which is 10. So this has to be 5 squared of 3. If you see the angles are 30, 60, and 90, then you can use the relationship to solve the sides. So let's look at this triangle. We see we have 30 degrees and 60 degrees and 90 degrees, and they only give us one length of the side, 11. So if we don't remember this special relationship, then we can't just use Pythagorean theorem. But if we do go, oh, this is a special triangle, I know that there's a pattern to it. And it was x squared of 3, and 2x. So which one is this? It's the short side, so it's that first one. And that makes it really easy. This side is x squared of 3. If x is 11, then we just have to put in 11 for x, and we get 11 squared of 3. This hypotenuse is 2x. If x is 11, then we just have to multiply 11 and 2, and we get 22 for our hypotenuse.